Hey guys, I'm Aisha and I'm sure you've all heard the term blood doping or blood boosting before. Well, my presentation will be focused on this, but specifically doping in the form of blood transfusions. So what exactly is blood doping? Well, the World Anti-Doping Agency, informally known as WADA, defines blood doping as the misuse of certain techniques and/or substances to increase one's red blood cell count, which allows the body to transport more oxygen to muscles and therefore increases performance. Blood doping through the use of blood transfusions is one such technique. It is a not-so-new method adapted by athletes wherein one removes, stores and reinfuses blood in an attempt to increase their performance. How is it done? Usually, 1 to 4 units of blood is removed a few weeks prior to an event. Each of the units contain about 225 ml of concentrated red blood cells. And because the blood is removed a few weeks before an event is due to take place, the resting interval between allows enough time to pass in order for the individual to re-establish their normal red blood cell levels before they are given a transfusion. This reinfusion of the stored blood can occur up to a week before the event and is used in an attempt for the athlete to increase the oxygen levels in their blood, i.e. resulting in a greater VO2 max, which is the maximal oxygen carrying capacity of blood. As a result, there is a greater increase in the athlete's performance and stamina levels because they are able to work harder and for longer periods of time. It has also been suggested that the increase in hemoglobin leads to extra proton buffering capacity and thus contributes to a decrease in lactate generation, but a rise in lactate threshold. Figure 1 demonstrates the difference between whole blood, which is on the left, and centrifuged blood on the right. Figure 2, on the other hand, highlights the different factors that determine the maximum oxygen uptake. As you can see, blood volume and hemoglobin concentration play a role in aerobic capacity. As a blood transfusion takes place, both blood volume and hemoglobin concentration increases due to the sudden increase in red blood cell mass, and thus aerobic capacity also increases as a byproduct. Although initially blood doping was intended as a medical use for the treatment of anemia, its benefits have been taken advantage of in an effort to provide athletes with an unfair advantage. There are two main forms of blood doping: autologous or homologous or allogenic. The former involves the same individual as both donor and recipient, while the latter involves the donor and recipient being different people, i.e. friends or family or someone completely anonymous. The first evidence of blood doping came about in 1972 when an experiment showed a generous increase in athletic performance after individuals underwent autologous blood transfusions. Since then, there have been numerous records that have shown athletes achieving higher levels of success in competitions after these transfusions. Blood doping quickly became very popular during the 1980s, especially during the 1980 and 1984 Olympics, after which the International Olympic Committee, also known as the IOC, banned blood doping. Recently, however, after the ban of substances such as erythropoietin and other blood substitutes, blood doping has made a comeback. In 2002 specifically, Austrian cross-country skiers were identified as having used methods of blood doping when competing and were disqualified as a result. Further recent investigations have also shown that participants in the World Ski Championships have reported deviated hematological profiles. These deviations were identified in 50% of medal winners, 33% of those who placed 4th to 10th, and 36% of those who finished within the top 50 overall. Alternatively, it was reported that only 3% of those who finished between 41st and 50th position had abnormal levels. In Figure 3, you can see that the popularity of allogenic blood transfusions have increased slightly over the last decade and a half, while autologous blood transfusions have undergone a slight decrease. Overall, however, the use of blood transfusions as a blood boosting method has remained quite constant. WADA have employed several different methods of identifying those who have undergone blood doping. However, it hasn't been easy as some of the initial methods had setbacks. This was because of the use of unpredictable thresholds that were put in place, as well as the fact that individual blood profiles were not taken into account. As you can see, for men, if certain oxygen-carrying compounds such as hemoglobin exceeded 175 grams per liter, they were banned, and it was the same for women who exceeded 155 grams per liter. Because of this, new procedures were developed. Identifying blood transfusions of an allogenic nature involves the identification of individual-specific red blood cell antigens. These antigens are generally unique and thus, through methods of blood testing, both donor and recipient may be identified. As you can see in Figure 5, each of the antigens on the blood cell have their own specific binding antibody. And because of this specificity, each individual has their own set of antibodies and antigens, making them easier to identify in blood samples. Recently, WADA have employed an even newer method of testing called flow cytometry. This method is based on identifying donor and recipient erythrocytes by flow cytometry. Flow cytometry allows for the detection of small populations of donor cells that differ antigen-wise from the recipient. This is based on phenotyping several red blood cell antigens, and because of this, the chance of detecting two identical samples is less than 1 in 500. Figure 5 demonstrates flow cytometry used to screen for allogenic blood transfusions. In step 1, they generally stain the cells with fluorescent labeled antibodies that recognize specific antigens on the cell before the cells are passed through a laser, and thus they emit light at varying wavelengths specific to the fluorescent labels. On the other hand, testing for autologous blood transfusions has been found to be much more limited. It has mainly been based on the use of identifying significant deviations from an individual's natural blood profile by noting changes to the levels of hemoglobin, serum erythropoietin, serum iron, and serum bilirubin. However, there are some setbacks to this. Manipulation is still possible by athletes as blood volume changes at different altitudes, and so if an athlete trains in different terrains, they could still test positive despite having not resorted to blood doping. It should also be noted that there are some individuals who have shown seasonal changes in their blood mass, and thus, because every individual is different, there cannot be one overall different reference range. So, as a consequence, more solid methods of testing are still being investigated. In conclusion, blood transfusions in the form of blood doping have become more popular as other forms of doping have been banned, and so, as a result, methods of testing for these transfusions have been forced to improve. There are two main methods of blood doping. There's autologous, which involves the same individual as the donor and the recipient, or allogenic or homologous, where two different individuals are required. Because of its advantages in sport, blood transfusions have been used negatively in order to cheat by increasing the blood oxygen capacity of red blood cells, and so methods for testing for blood doping have been forced to be developed to protect both sport integrity as well as being employed for health reasons. However, there are still some significant drawbacks leading to further investigations. Thank you.